Hi GeoR, this is Unit 3, Lesson 7, and we're doing hypotenuse-like proofs. So I saved the best for last. There's only 8 lessons, so we're almost at the end of proofs. I know you're having so much fun doing them. Hypotenuse-leg proofs are probably my least favorite, only because students tend to mess them up. So hypotenuse-leg proofs, you have 2 right triangles, and they're congruent because the hypotenuses and one of the legs. It doesn't matter which set of legs we have. So I have a picture right here, triangle ABC, triangle DEF. So you can see that they're both right triangles because I have angle B is a right angle and angle E is a right angle. And then they have the hypotenuse and they have one of the legs. So this is really like an angle side-side proof, which, as we've talked about before, is not a way to prove triangles congruent. But because it's a right triangle, it actually works. The tricky part, the part that people mess up on this, is that in order to use hypotenuse leg, you have to first state that the triangles are right triangles. So that's super important. Now, if you left that out, is that the end of the world? No, you're just going to lose a point or two, depending on how many points the proof's worth. All right, so let's look at number 1. I have CM is congruent to DM. I'm going to mark that on my picture. I have CA is perpendicular to AM, so that makes this a right angle. I have DB perpendicular to BM, that's a right angle. And M is the midpoint of AB, which means it cuts AB in half. All right, so I'm going to start with my given. Again, everything that I just marked, I'm going to write as my proof. What you're marking on your diagram is really just for you. The proof itself, what's being graded, is what's written in the statements and reasons. Okay, and everything that we're learning in proofs, you generally on a regions of proof is just one question, but all the other stuff we're learning along the way could be part of the multiple choice questions. So there are, other ways that they're testing this rather than just writing a whole formal proof. As we said, that I have some perpendicular lines here. Perpendicular lines form right angles. That means angle 1 and angle 2 are right angles. How do I know that? Well, because perpendicular lines form right angles. Definition, perpendicular lines. And if they're both right angles, they're actually congruent to each other. Angle 1 is congruent to angle 2. All right angles are congruent. And I also had that M is the midpoint of AB. I already marked it on my picture, put a big fat dot on M, and I cut AB in half. But now in my proof, I'm going to say which halves are congruent. So the left half, which is AM, is congruent to the right half, which was MB. How do I know that? Well, a midpoint divides a segment into 2 congruent segments, or just definition midpoint. Now, if you're looking at my picture, I have angle side-side. And angle side-side is not a way to prove triangles are congruent. But I also notice I have 2 right angles, so those are right triangles. I have the hypotenuse, so CM is a hypotenuse and DM is a hypotenuse. And I have one of the legs, that was the AM and the MB. And before I can use hypotenuse leg, though, I have to say they're right triangles. So triangle CAM, let me fix that because that's super messy. And triangle CAM and triangle DBM are right triangles. Not that they're congruent, I'm going to do that in a second, but they're right triangles. Now, how do I know they're right triangles? Because they have a right angle. All right, so they contain a right angle. And I said they had a right angle back here in step 2. Now, if they are right triangles and I have a hypotenuse and a leg, now I can say they're congruent. So triangle CAM is congruent to triangle DBM, and the reason is hypotenuse leg. Okay, so that is a hypotenuse leg proof. What rigid motion maps one triangle onto the other triangle? Well, if I had a line right smack down the middle, right that, then A would map to B, C would map to D, and M would map to M. What line would that be? It would be a reflection over the perpendicular bisector of AB. So that red line that I drew was a perpendicular bisector of AB, and if I was to reflect the triangle over that line, everything would map onto its corresponding angle on the other side. All right, let's look at the back right here. So prove the following using any method of triangle congruence that we have discussed, then identify the rigid motion that would map one triangle onto the other. All right, so move this up a tiny bit more. I know that AD is perpendicular to BD. I'm writing my given. BD is perpendicular to BC, and AB is congruent to CD. That's all my given. Let's go to my diagram, mark it up. We're going to talk about those perpendicular lines because obviously the perpendicular lines form right angles. But I have AB is congruent to CD, and I have BD is perpendicular to BC, so that makes this angle a right angle. And I have BD is perpendicular to AD up here. So that's a right angle also. So let's say angle 1 and angle 2 are right angles. I know that because perpendicular lines form right angles, or definition perpendicular lines. Now once I say they're right angles, then I can say they're congruent to each other. Remember, these two steps always come together. They're like best friends. First I say they're right angles, then I say they're congruent because all right angles are congruent. Okay, and then you can see what I have so far. I have two right triangles. All right, those are right triangles because they have a right angle. AB is actually the hypotenuse of the triangle on top, and DC is the hypotenuse of the triangle on the bottom. They share that side in the middle. So BD is congruent to BD, reflexive. So BD is a leg of both triangles. So I already said I had the hypotenuses. These are the hypotenuses over on the side, and this in here is the leg. So all I have to do is I'm going to be using hypotenuse leg, but remember, in order to use hypotenuse leg, you first have to say that they're right triangles. So I'm going to say triangle ABD and triangle CDB are right triangles. And the reason is they contain a right angle. I said in step 2 they had a right angle. Now I can say that the triangles are congruent. So first I say that they're right triangles. I have the hypotenuse and leg. Oops, I need to say that they're congruent. And I forgot that. Is congruent to triangle CDB, and the reason is hypotenuse leg. All right, and I have one more. Given BC is parallel to EF, I'm going to change colors here. So BC is parallel to EF. And D is the midpoint of BF. Now it's the midpoint of BF, so it's cutting BF in half. So let me go to BF and cut that in half. All right, so that's all my given. Now parallel lines, especially the ones that look like this, they make alternate interior angles congruent to each other. So I'm just going to put a 1 and a 2 on those alternate interior angles. All right, so I have, or I can actually just say angle C and angle E. Angle C is congruent to angle E because they're alternate interior angles. And angle B, let me mark those. Angle B is also congruent to angle F. Those are also alternate interior angles. Alternate interior angles are congruent. Now, you might have been saying, well, I also have these vertical angles right here. Yes, you could have done that. That would be perfectly fine. But I don't need to, so I put green dots where those vertical angles are. I don't need to do that because I already have enough to say these triangles are congruent. I have angle, angle, side. So since I have angle, angle, side, I'm done. If you want to do the vertical angles, then you could have done this by angle, side angle. All right, there's a bunch of different ways you could have proved this. So the triangles are congruent. So triangle BCD is congruent to triangle FED by angle, angle, side. But I'm trying to prove that ED is congruent to DC. Remember, first I prove the triangles are congruent, and then I can say any of those corresponding parts are congruent. So ED is congruent to DC, and the reason is CPCTC. CPCTC. Corresponding parts of congruent triangles are congruent. There are two ways not to prove triangles are congruent. We've sort of mentioned these. Angle-angle is not a way, or angle-angle-angle, and side-side angle or angle-angle-side, and I will show you that tomorrow why side